Alright, so we're going to be doing section 3.3, future values of annuities. So far in our time value of money type questions, we have been dealing with single payments, like one lump sum payment. If I invest $10,000 into an account today, how much will be in that account at some future date? But we don't have to make just one payment, we can make periodic payments. So we can make periodic payments like once a month, once a week, once a year. So we can continue to make payments and see how much money is in that account at the end of some time. So the equation for the future value of annuity, we say the future value equals the payment times 1 plus I raised to the n minus 1, all divided by I. Now, I don't know about you, but when I look at this big old equation, this is an ugly guy. I don't like looking at that. So we are not going to be dealing with solving these types of problems algebraically. Rather, we are going to be using the nice features on our financial calculator with solving for these types of annuities. So we are going to be dealing with the future value. FV is still going to be the future value, how much is in the account at the end of all of our payments. Future value. PMT equals to payments. This is our periodic payments into the account. I, once again, is going to be our per period interest rate. And then N is the number of payments. Number of payments. So, a standard question that we might be looking at might be, have after 20 years of annual $2,000 payments into an account with annual interest rate of 8.5% compounded annually. So I'm going to make 20 years of payments of $2,000 payments every year into an account that earns interest at 8.5% compounded annually. So let's take a look at some of the information that we have in here. So we are looking at how much is going to be in the account after 20 years, so that we know that our T equals 20. And because we are compounded annually and we're making annual payments, we know that our N, once again, is still going to be our T times M. So in this case, it will be 20 times 1. If we're making annual payments, our M equals to 1. So 20 equals our N. Alright. If we're making we're making $2,000 payments, we know that our payment is equal to negative 2,000. So $2,000 is leaving our bank account and going into this interest earning account. So we're making payments of $2,000, and that is why we have that little negative symbol right there. Alright, Our annual interest rate is 8.5%, so R equals 8.5. But remember, our per compounding interest rate is R divided by M. So in this case, we'll have our annual interest rate divided by our M that's associated with still 1. So quite nice and conveniently, 8.5 is also equal to our per compounding interest rate. So let's look at this. We have our N, we have our PMT, and we have 8.5 equals I. We have 3 of the 4 from up here, and that's what we typically are looking for. We typically obtain 3 of the 4 bits of information of these 4 variables, and then we are going to be able to solve for the 4th given that we have 3. Alright, so we can plug in 20 for N. We can plug in 20,000 for PMT. We can plug in 8.5 for our I, and then we are going to compute for future value. And then after we compute for the future value, we're going to get a future value of $96,754.03. So that's how much money is in the account after 20 years of annual $2,000 payments. Alright, so let's think about this a little more. Given that we know that there's going to be $96,000 left over in the account after 20 years. We're making 20 years of $2,000 payments. We might be interested in how much did we earn in interest. So future value equals $96,754.03. How much did we earn in interest? Well, interest earned is simply going to be the future value minus all the payments that we made. So this is reflecting how much money we put into the account. The future value is representing how much money is in the account at the end of all of it. The difference between these two will be how much money we have earned in interest. So in our case, we're going to have $96,754.03 minus 2,000 times 20. So 2,000 times 20, that simply is 40,000. So 96,000 something minus 40,000 something, we are going to have $56,754.03. So this is how much money we have earned in interest. We put $40,000 total into the account with the sum of all our $2,000 payments, and then we have 96,000 something at the end. So that means that we have earned $56,754 just in interest. So that's kind of a nice thing to note. Alright, so we have done an example in class already of earning. I have a wonderful little son, and I want to make sure that there is $80,000 in an account at the end of 17 years in order to pay for his college. And guess what? I don't have a lump sum amount of money that I can put into an account today in order to make sure that I have $80,000 into the account 17 years from now. But we can calculate how much money that I can put into an account periodically to make sure that I have $80,000 in the account at the end of the time period. So we got future value of 80 grand, and that's for his college. Alright, let's assume that my account is a 6% annual interest rate. And this account is going to compound monthly. Alright, It's going to be 17 years. I'm going to make monthly payments. And we want to know how much money do I have to invest every single month to make sure that there's $80,000 in this account at the end of the year. So we need to figure out 3 of the 4 appropriate variables. And we already know that the future value has to equal to $80,000. Alright, we know T equals 17 years. And that implies that our N, once again, is going to equal 17 years times our M. And if it compounds monthly, that implies our M equals to 12. So 17 times 12, well, that's 204, of course. That is our N. And now we know the future value. We know N. We now have to figure out what I equals to. And I is going to equal to the annual interest rate divided by our M, which equals to 0.5%, and that equals to our I. So we now know what our future value is, we know our N, and we know our I, and then given that we have 3 of the 4, we can solve for the 4th. So we are going to plug in 80 grand for our future value. We want to make sure there's $80,000 in the account at the end. Alright, we know that there's going to be 204 payments, and the per payment compounding interest rate is 0.5%. And then we are going to compute for the payments. And we are going to get a payment equal to, let's see, what did we get? Payment equals to negative $226.48. So why is it negative? Well, remember, I'm going to be making payments into this account for 204 times over the course of 17 years. So that means that $226 has to be leaving my pocket over the course of time. So that is the payments that I'm going to be making into the account over the entire time period. And that's how I can make sure I have 80 grand in an account ready for him to go to college, is that I can make monthly payments rather than the one lump sum payment. Alright, so that kind of is our lesson about going over the future value of annuities. Take care now.